water resources allocation in East Java, Indonesia, integrated assessment of the hydrologic and socioeconomic impacts of climate change in the Volta Basin, West Africa, development of water use rights in Indonesia, sustainability of groundwater irrigation in India, and also modeling and simulation studies of agriculture and water resources in the US Midwest. Dr. Charles Rogers, you are welcome, please.
Thank you very much. Can everyone hear me? I guess the advantage of being last is that everyone has said anything of substance that I intended to say. In particular, Professor Polutikov, I think, stressed the point that I wanted to make, that the scientific community, the atmospheric science community, has been very good up through AR4 in addressing the issues of basic science related to how the atmosphere and the coupled Earth-ocean system will respond to increases in GHG forcings. I think we know that and we appreciate it. But now a different task is called for, and that, of course, is to produce end-user relevant products. The folks at NCAR are calling these climate services right now and have actually set up a division to provide them. And we can take, for example, things like medium-range weather forecasting that has always, if you look back decades, progressed even as the science behind it was perfected and was and continues to be a useful tool in that context. Now the IPCC, the CMIP-5, which are the model runs that are going to underlie the IPCC AR5 due sometime early 2013, I believe, are actually anticipating this. I don't know how well known it is, but they've placed a lot of emphasis on what they call near-term projections, which are basically 30 years out, a 30-year projection horizon at higher model resolutions than the longer-term experiments. And the intent is very much to put tools in the hands of users, end users, who are actually required to make decisions, water resources, agriculture, health, and so forth. So I think we should also be thinking about how we should position ourselves to benefit from these products. It's really not so long from now. And as our VP stressed this morning, here is a natural role for climate services as regional public goods. Now this public goods, I mean, this is economic jargon, but basically a public good is something that isn't diminished by each successive use. And so if we create, for example, an ensemble or a suite of projections for downscaled projections at very fine resolution for South Asia or Southeast Asia, they're available to everyone. Every project that has a requirement for such tools, or every national development activity, can find them, and it in no way reduces their availability to other parties. So I think the question I would actually put to this group here is, how can we best organize our efforts to ensure the provision of these and related regional public goods? And by related public goods, I would include short to medium range regional weather forecasting and disaster early warning systems, because neither climate nor disasters respect political boundaries, and there is a strong rationale for treating these things as public goods. I'll keep this brief, again, since so many of the points I think have been very well made, but from my perspective, perhaps because I've worked in agriculture and water management, I think that when we look at the agenda in front of us, there's a tendency to focus on the climate modeling community, how they need to provide us with higher resolution, with increasingly large ensembles of high resolution products. But all of our binding constraints are not in atmospheric science. I think we have a lot of work to do in the area of terrestrial hydrology, far more than many of us realize, in particular groundwater, so important in Asia. Very few of the models in use right now really get at the fundamental issues of what climate change impacts will be in particular basins and locations on groundwater recharge. We can perhaps look at the demand side a bit more clearly than the supply side, but that will be important. A second area is in agricultural science, and not just limited to production agriculture, but I guess bioscience in general. We don't even know at this point with confidence whether CO2 enrichment and its impact on, for example, stomatal control will allow production agriculture to use less or more water, to produce the same yield, because we have two competing phenomena that are both driven by either temperature or CO2. So those are close to the top of my agenda, research agenda for the near term, the next decade or so. And so I'll leave it at that. Thank you very much.
Thank you very much, Dr. Rogers. Ladies and gentlemen, now I would like to open the floor for discussions. The comments, questions, welcome. We have many distinguished